Okay, so here is our playlist, YouTube playlist. So over here, just as a reminder, on the top part you have, let me just see here, oops, here. On the top part we have all the lectures that we're doing, and this thing keeps populating as we go along. So here's the lecture that we have, here's the lecture, all right, all that stuff that we have done. And last one was this here, wiring, T568 wiring and security alarm. We're jumping through topics here. And the last one, that's the last one that we did, and this is a repeat for the other sections. Okay, so both of them are placed here on our YouTube playlist. Now I have already populated this with the optical fiber or fiber optics part 1 of 2 and part 2 of 2. All right. Now those two I'm going to ask you to review at your own time. This is this week's content. There are a couple of reasons why I want you to watch these two particular videos. It is because I did them a year ago, and when I was going through them last week, I just looked at them. So, and you know what? Those two videos, they came out the way I wanted to, right? And I'm not sure if I can repeat them exactly the way that's on this video here. I could could possibly miss some aspect of it or not, but I'm happiest with those two. So I'm just going to ask you to watch these two videos. This is for this week, all right? And then we're going to also designate separate one of the part of the next week's lectures in order to just kind of review that and I'll go over it. And if there's something that that somebody has some questions about these two videos or this particular topic, one is the first one is it's the overview of how optical fibers work and the structure of that. And the second one is the practical applications that we're doing. We're also going to have a lab. I think this is the last lab that's associated with that. And we're going to perform a fusion splice on couple of single mode optical fibers. Right? So you're going to actually play with those, with the fibers. All right, but today also it's there's another possible reason for which I want you to view those things this way, right? And of course, after the last posted lecture, we have labs, right? So this is the lab that we're doing right now. No, actually this one here. Currently, we're performing this 25 pair termination, and this week is the B groups, the B subsections of the groups or sections. And already I have posted a preparation video for the patch panel termination. Okay, so it's about an hour video. So it's a part of it is you get some theory overview on that, and also the full-blown version of the instructions of what exactly we're going to do during those labs, during that particular lab. And also this, okay, so this 25 pair termination, we only did one during that lab session, and this one here also we're going to perform only one lab. Right? Some of them, some of the labs are a little bit shorter, so we can fit two during one session. And I just decided that these require a little bit more attention as far as detail goes. And it's a little bit more labor intense. So this one here is just one lab per week, and also the next one, patch panel, is going to be one lab per week. All right. So again, please watch these two, and there are a couple of there in this these posted lecture notes. Let me make them visible. Okay. So here, content. student items. Where are we here with the student items? Yeah, we're student items, lecture notes, and they're invisible. You can't see them yet. And make visible to users. And this one here, make visible to users. So now you can actually have access to those. All right. Okay. So now we're going to continue with the previous lectures, the previous lecture. I just want to finish that up. So you know, it might be a little bit shorter today, but then again, I keep always saying that, and it ends up being a full hour. Let's see how we can do with this. All right. So last time what we talked about was the security alarm portion. And again, this is not a full instruction. You know, after this, not necessarily you will be able to just go and purchase a security alarm and get the proper parts for it and install it properly and know what you're doing. It is you're getting an idea of what it is and what is involved, and you're getting some terminology and the technical lingo that's associated with that. All right. So when if you get hired by a company that does these kind of things, you probably, for starts, you probably are going to be sent with somebody else who actually is doing that already, and you're going to be first, you know, assisting them with all these duties and all this works that are happening during the installation. And while you do that, you're going to learn some details as far as particular ways of mounting certain devices and things like that. So you're going to learn on the job. And also, if it's later on, when you're going to get trained on particular systems, particular brands and models of the security alarms, and by the way, those training sessions are organized by the manufacturers, right? So if you get hired by a company that does these kind of things, then that company has a relationship with a distributor, and the distributor is in a relationship with the manufacturer, and the manufacturers send their representatives for training sessions, and the companies get notified that week so-and-so there's going to be a rep from Paradox or DSC or whatever else company, and they're going to present so-and-so security system. So usually you go there for, sometimes it's a day session, sometimes it's 2-day session, sometimes it's a whole week. So you know, you might get sent to like Mississauga or something, or some other city that the distributor is located. And they will fill you up with coffee and donuts and sandwiches, and they will present that. So this information that you're getting from me is getting you in a way that that you know what they're talking about when they're going to be training you, right? So so you get the technical lingo that's associated with that, right? So in this way, you're not going to have to research the terminology that's associated with all that stuff, because usually what happens is that when somebody gets trained on a particular model of security system, or a phone system, or a school PA system, or some sort of a home theater system, whatever it is, all right? Usually there are people who already are in this business and they have installed some other brands or other models, and then they're just getting introduced to one more model and the details that are involved with this particular system, all right? So when this information, again, that you're getting from me is that my objective is to give you enough information so that when you're getting trained, you know what they're talking about, okay? All right, so I just keep, before I start talking in circles, let's move on to the next thing. So as far as security alarm, now here's the idea of a fire alarm, right? What do we see here on this particular picture? Right? We see a main main fire alarm panel, and it's associated with the Enunciators, sensors, and some other paraphernalia that is connected to it, which has to do with the communications. So sensors or triggers. In this particular one here, we have a trigger. What do we have as a trigger? We have a pull station, for example. So you see those pull stations that are distributed on the walls of the building inside. And over here also you can have heat detectors and smoke detectors. Mostly when it comes to fire alarms, you usually get three type of basic devices: pull station, smoke detector, and a heat detector. And of course, the pull stations have various different variations, but mostly it is basically you just come over and you just pull the pull station to trigger the fire alarm, right? When you see a fire. Also, heat detectors and smoke detectors, they have different variations of that. But for the most part, you get heat detectors and smoke detectors. Some of the smoke detectors are mounted in the ceiling, and some of the smoke detectors could be mounted in the air ducts, for example. So that's how they might vary, right, for whatever different purposes. All right, so over here also you have a bunch of heat or smoke detectors, and over here also you have a bunch of heat and smoke detectors. And over here, I'm not sure if you can see that. So these are three different types of zones that you can encounter, and you can put different devices in the same zone. So on the same zone, you can have a pull station, heat detector, smoke detector, and over here there is something that looks like a sprinkler. All right, so I'm not sure if sprinkler will be part of that, but sprinkler is usually on the output or on the input, as far as when the sprinklers are activated, then the sprinkler system that basically stands on its own could have an output that is connected to an input of the fire alarm panel that could trigger also some chain of events, and mostly will be communication and fire alarm sounding, which will be a loud annunciating noise that there's a fire alarm, and it could also trigger a communication with something that's called a monitoring station. Right. Also, with the communication part of that, you could have the telephone line, or could be also a network, depending on the setup, and that could be connected to a receiving station. It's called, but this is just another name for a monitoring station. We went over that last time. Right? It could also go through a modem and a PC, and this idea is here so you can access the system remotely in order to do some programming. So that's the basics of the fire alarm. Now, when it comes to fire alarm, there is usually, pretty much always, there's some additional training and licensing required, depending on the jurisdiction, if I could say. So in Ontario, you could have some different set of rules that you have to go by as far as the additional special trade type of like professional training that you receive, that you might have to get some of that, and based on that you might have to be licensed in a certain way in order to perform certain duties as a fire alarm technician. Now, colleges across Ontario, they offer the fire fire programs, and also our college offers that program as well. So if something like that appeals to you, talk to me, and I might point you in the right direction of who to talk to in order to sign up for a possible additional courses or training. Okay, it is offered in our college. All right, so what's the next slide? Basic concept. Here is just another visual of fire alarm. So here would be the main panel. The difference between these two pictures is that there's just one basic fire alarm panel, and over here you have some satellite panels. So you could have main fire panel with all the paraphernalia connected to it, which would be triggers, annunciators, and communication part of it. And over here you have some satellite panels that could be a main panel somewhere located somewhere in the building, And in another part of the building, there could be another additional panel just to, it would work as a satellite of this one. So you don't have to walk across the whole building to the main panel to see what's happening as far as, fire alarm would be triggered and where possibly the fire could be. So you could take a look at this satellite panel and without having to go, depending on the size of the building, you might have to get some of that. So those remote panels or satellite panels could look like this. They could look like that. And smart ready module that it's also basically serves with some communications part of the whole main panel. Different brands offer different setups, okay, but the basics are the same. You get a main panel and you got the things connected to it, and those things I mean by Enunciators, which would be a noisemaker and a strobe light, and depending on where you are, but usually it is required that that there's a certain level of noise that is enunciated across the whole building, and and a strobe light that is associated with that. Now, when it comes to fire alarm, also fire regulations, it's also required that commercial buildings do have some form of a PA system. All right, so the PA system is not just a convenience for the management to do announcements and whatnot. PA system is also a part of a safety regulations. All right, so the reason why the PA systems has to be there. Sometimes one of the reasons is that if there is some sort of a hazard present, or situation or condition, such as fire, then the management has to be able to enunciate the condition to everybody, and the announcement would be, "This is false alarm. Please ignore it," or it could be, "This is not a training. This is not a drill. It is a real fire alarm. Please leave the building now." And then all kinds of procedures are triggered. There are people inside the building that are designated as persons that organize the getting out of the building procedure. Right? So in some cases, the PA system could be a separate standalone system, and it could be connected in the way that we have connected. It could be one of the connections. Sometimes you will have smart speakers or smart speaker stations that require power, and they're connected through Ethernet cable. And sometimes the PA system can be also part of the fire alarm system, right? So as far as the enunciating modules, that module could incorporate a noisemaker, right? A strobe light, and a speaker, right? That could be used to do the announcements. So that let's see here. Now, how is the zoning solved? Remember, zones are trigger points, and same as security alarm or a fire alarm can have zones, and a zone is a triggering circuit, and usually there is no less than 8. Sometimes some of them have 16 zones, and sometimes you will have a fire or security alarm capable of 8 zones, and then with the possibility of expanding to additional maybe 8 or 16 or 32, depending on how big the system has to be, right? And the zone is a triggering point to which you connect sensors. And the sensors or the zones can be organized. Like, for example, one of the triggering points, which would be the zone that's connected to the main panel, it could have 2 wires going in a bus type of a configuration, and it could extend along all the length of certain hallway, right? And in that hallway, there could be a bunch of smoke detectors pinned up to that zone, and that zone could be called East Wing Hallway Smoke, right? Or something like that. Or some other one could be connected, some other trigger point or that zone could be connected also with 2 wires. And it could be also extending along the same hallway, And but to that one, you could have a bunch of pull stations connected to that. So so if somebody pulls a pull station, the annunciate the main panel would be annunciating that there is a pull station activated in such and such hallway. So it would be a name of the zone, right? So and there could be other zone could be connected, have a wire that is going along certain air ducts, right? So if there's a fire in the furnace room, the smoke would go in the air ducts. So there are smoke detectors distributed inside the air ducts, and they're sensing a smoke, presence of the smoke. And if that all those smoke detectors along certain air duct are connected, it could be connected. So the zones are basically connected in a way that that could be organized in certain ways, and you can combine pull stations with smoke detectors in one area if it's a smaller building and things like that, right? But the way and the possibility of combining different triggering modules or triggering sensors, it also should comply with the local rules and regulations. So how is it? Okay, remember when we talked about the security alarm? Let me see if I can quickly bring up the zoning. Well, there it is. So in a security alarm, remember we had the zone, and we would have a loop with the devices connected in series. Because usually, unless it's an end-of-line system, right? Usually it would be that the loop has to be closed, and the sensors would be opening, suggesting a condition. So if the door contact opens on a certain door, that means that the door is open. If there's a motion in the room that the motion sensor is located, that the motion sensor would have a dry contact relay that would open based on motion that was detected. So you mount those devices in series. So if any one of them triggers, it opens the loop and the zone is being triggered. So everything is in series. All right, now let's look at the fire alarm. It's a little bit different. Things are in parallel. Oh, there. Things are connected in parallel, all right? So if this is a zone, the zone has to see an end-of-line resistor, EOL resistor. Now, and it's not quite often it will be a 47 kilo ohms, but depending on the brand and model number of the fire alarm, the values of the resistors might vary. Okay, so it's up to the specifications of the particular system. So when the zone is at rest, okay, there are two, well, maybe screw terminals or whatever the terminal would be, a point A and a point B. So it has to see the resistor at the end of the line. Now, sometimes if it's installation that is wrongly done, some of the technicians, I have seen that in the past, they have mounted the end of line resistor right at the point where the zone leaves, when the wires leave the zone. That is a no. It's wrong. The end of line resistor is nomen omen, end of line resistor. Yeah. Nomen omen. What's nomen omen? Nomen omen, it's a Latin expression of saying the name of the thing describes its function. So as the name of the resistor suggests, end of line, it's an end of line resistor. The purpose of the end of line resistor is, so when the zone is at rest, it sees the resistance of the end of line resistor. It senses that resistance and it thinks that, in quotes, that the zone is good. It's fully functional and there is no conditions. There are no conditions. And condition will be a fire alarm, right? For example. Right? So what happens is that if the system, if there's a break in the wire, because notice those devices, as opposed to normally closed in a security system, in a fire alarm, all the devices have open circuits. So if the device does not trigger, if there's no condition, if it does not sense a condition, it has an open circuit. So the system doesn't even see it. Right? So the purpose of the end-of-line resistor is just to make sure that the whole wire, the whole cable, the whole loop is intact. If there is a break in the line, then the system is not going to see the end-of-line resistor. It's going to see a huge resistance, which basically could be considered as infinite resistance. And it is going to not think that everything is okay. Actually, it's going to think that something is wrong. And it is going to go into condition that is called a trouble condition. A trouble condition is not a fire condition. It just means that there's a trouble. And what does it mean that there's a trouble? There's a trouble with the wiring of the zone. So it could be broken cable somewhere in the middle of the line. Now, if somebody puts the end-of-line resistor right here, the system is going to think that everything is okay, but is really everything okay? Because if there's a break in the line here, and if you have a resistor at the beginning of it, then that system is not going to detect the break in the line. So end-of-line resistor has to be at the end of the line. Now, what happens? So one of the conditions would be a trouble. If the line is broken, the resistance, the specific particular resistance that the system is looking for, it's not going to be present. Something else is going to be present. It's going to be infinite resistance. So then the system is going to go into trouble condition. And how is that going to manifest? The main panel is going to produce periodic annoying beeps to the point that somebody is going to get up of their chair and going to look at the security. Where is the noise coming from? Oh, it's coming from the fire alarm. Oh, okay, what's happening? And it says trouble. It's just going to say trouble. Right? And of course, there's going to be a phone number usually, but right on the panel for assistance, call, blah, 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 and there will be a phone number. So, and this could be also, in case of trouble or whatever else, call this number. So they're going to call that number and they're going to explain. It says trouble, okay. Then we're going to deploy a technician to check what's happening there. And trouble is not a fire. That means there's trouble with the way in a way that the system is not necessarily fully functional. So the ability of detecting a fire is compromised, right? But that doesn't mean that there's a fire, not necessarily. Well, it could be, because the fire could be burned. There could be actually a fire, and it could burn the wires, all right? But chances of that are slim, right? So that's why we need the end-of-line resistors. Now, what happens when something happens? What happens when something happens? What happens when there's a fire condition? So let's say there's a smoke present in one of the hallways, and the smoke detector, let's say this one here is a smoke detector, and if that smoke detector senses the smoke, it could be in the hallway, it could be a smoke detector in the air duct, or it could be a heat detector somewhere close to the furnace room, or it could be a pull station that is pulled, or it could be a sprinkler system that triggered and then that has activated, and based on activation of the sprinkler system, the circuitry that's associated with the sprinkler system could trigger a contact that is connected to a zone, right? Whatever it is, right? It is going to close. So what is the system going to see? It's going to see a zero resistance. It's going to see a closed loop. And in this case, it's going to think that it's a fire. And based on that, it's going to trigger a bunch of chain events. It's going to annunciate in the fire, in all the devices, which be the noisemakers, sounding alarms, and strobe lights. And then whoever is present in the building, they can just walk up to the panel and see. And of course, in the panel, there's going to be a fire condition. And it's going to annunciate in the panel, fire, hallway, east hallway, something, all right? Or pull station, west hallway, whatever it is, right? Then based on that, there are procedures to follow, right? So that's how the zones of the fire alarm work, right? Now, in the fire alarm, here's a basic overview of what could be involved with the fire alarm. Well, first and foremost, we have the sensors, right? And the sensors usually classify as heat detectors and smoke detectors. In some cases, it is better to install a smoke detector because in such, like for example, if it's a hallway, if there's a fire, there's a smoke. So smoke would be the first indication that there's a fire. Right? Now, close to a furnace, in the furnace room, there will be a fire first before there's a smoke. So the things are going to heat up, and the fire that's present in that room is going to trigger the heat detector. So sometimes it is more proper in certain situations to install smoke detectors, and sometimes it's better to install heat detectors based on the situation that you're in. All right, so sensors, heat detectors, smoke detectors, and manual, which would be the pull stations that are along the hallways. They just pull the station to trigger the alarm. Annunciators would be a bell or siren. Siren quite often is called a bell, or there could be a piezo noisemaker, piezo annunciator. It's also called a siren, or quite often it's just called bell. Because there could be different types of, you don't want to get into technicalities of how exactly this thing is made, or maybe what type of plastic was used to make the chassis for it. No, it's quite often you're going to see the bell. All right, so that's what it means, right? And strobe lights. Yeah, so they'll be basic annunciators. Interfacing. Fire alarm can be interfaced with a security alarm, or vice versa. Yeah. Monitoring. Monitoring is same as security alarms. A lot of companies that install fire alarms, they also offer security alarms installations, because those two go hand in hand quite often. They're very similar. So there could be a security company that also offers fire alarms. There could be an electrical company that also installs fire alarm systems, right? So, but the security alarms and the fire alarms can be interfaced. Like, for example, that depends on the area and the rules and regulations that apply to the area. So the code and the rules that apply to certain areas should be reviewed before connecting things in a certain way. But what is possible? For example, the examples could be that the security alarm could be connected to a monitoring station and the fire alarm not. So then there could be an output relay of the fire alarm that could be connected to one of the inputs or one of the zones of the security alarm. And if there is a fire, then the fire alarm triggers one of the inputs or the zones that is programmed as a fire alarm zone, and the security alarm senses that, and the security alarm makes contact with the monitoring station, indicating that there's a fire. Right? And then there are certain procedures that if that zone is triggered, the monitoring station has specific instructions of what to do. Now, sprinklers interfacing. We're talking about interfacing. The fire alarms can also be interfaced with a sprinkler. Now, if there's a sprinkler system, the sprinkler system can exist on its own. And we haven't even talked about the sprinkler systems. Sprinkler systems are basically sprinklers. You can see those sprinkler heads. Quite often they're exposed, some of the older ones, and sometimes they are flush, they're covered. And if the sprinkler system activates, the sprinkler head pops out and spreads water on that. So how do they work? Well, the sprinkler system could be dry or they could be wet. The wet sprinkler system means that in the pipes, because it's kind of a plumbing system, all right? So there are a bunch of pipes along the building, and out of those pipes there are sprinkler heads, all right? And the sprinkler heads have sensors. Usually when there's a heat there, the sensor gets melted and it triggers that particular sprinkler system. Usually the only one that's triggering, it's not like in the movies that you break one of them and the whole system goes off. Yes, it's a possibility. There are certain systems that if one triggers and the whole thing triggers, all the sprinklers are going to spread water. But it's a very rare situation. Usually the one that triggers is the one is going to spray water and the other ones are not going to. What happens when the sprinkler system is triggered is that the pressure, because there's a water under pressure in those pipes. If the sprinkler system triggers, the whole pressure drops because there's an outlet for the water. So the pressure in those pipes is not going to be as great as if nothing was triggered. Right? So the pressure of the water in those pipes goes down, and that pressure of this water going down is being sensed by the main circuitry of the sprinkler head or the sprinkler system. And when that is being sensed, then the sprinkler system on its own could have a communication circuitry that can communicate with the monitoring station. Or that output of the sprinkler system could be connected to a fire alarm system, or it could be connected to a security system, but usually it's the fire alarm system, right? So that's what I mean by interfacing sprinkler system. The other sprinkler system would be dry sprinkler systems, and that means that the pipes that are connected to the sprinkler heads, there is no water in them. Right? It's just air inside. And when the sprinkler head triggers, then the water is being released from the main sprinkler system panel, and it's just flooding the reason why would we have dry or wet systems? Well, the wet systems are more they trigger quicker. The water comes out quicker, but they can only be installed inside of a building that there is normal heat in the winter and so on. But let's say if it's a sprinkler system that is installed in the outside garage, like for example, like there's a hospital and there's a huge outside garage that you can park your car, and there's no walls. The whole thing is basically exposed to the outside elements. So if there was water in that, then in the winter the water would freeze in those pipes. So that's why in that case you would have to install something that's called a dry sprinkler system, so that there's no water, but in case there's a trigger, then that triggering of that specific sprinkler head would trigger the water being released from the main panel, right? So that's a different distribution between dry and wet sprinkler systems. The fire alarm can be also interfaced with the PA system, so the fire alarm could have a audio circuitry connected to a microphone or connected to a phone system from which the audio can be distributed towards the whole facility. And sometimes there's a separate speaker system, separate audio distributed system, and sometimes the annunciating modules would have the noisemaker. I call it a noisemaker, or sounding alarm, or it could be also associated with a strobe light. And third one, there could be a speaker, a PA speaker, as part of that annunciating module. Right? Kitchen fire suppression. Kitchen fire suppression systems can also be interfaced with the fire alarm panel. What is a kitchen fire suppression system? Some of you probably have jobs in maybe some fast food places, and whenever there's a grill or something, there's a fire there in the kitchen to grill the burgers or whatnot, you're going to see some specific different kind of nozzles on top of whatever the heated station is, or a hot plate or a grill, and there will be some nozzles, and they do nothing. They just sit there, right? And there could be some other sensors there. So if there's a fire in there, there's a sensor, usually a piece of PVC or specific material that can withstand the heat of the normal grilling process or normal operation of the whatever the kitchen station is. But if the temperature goes a certain way, too hot, if there's a fire, that thing is going to break, and the spring-loaded action is going to release some triggers, and then there's a system with fire suppression chemicals that are going to be released through those nozzles to suppress the fire, right? And usually will be a oxygen suppressant that first is going to be sprayed on top of that. It looks like a foam, right? And then followed by water, right? So it depends. We do have one example of that in T1023 upstairs. Sometimes when you're there, ask your professor to show you that. It's upstairs in those where the cubicles are. It's upstairs. There's a kitchen fire suppression system installed, right? It's you can trigger that, but don't trigger it by yourself, because that thing also is connected to some other things. So ask for demonstration sometimes if it's possible, right? So first in the kitchen suppressions, there's a oxygen suppressant released onto the plate, but since the plate is still hot, so it could reignite. The fire could reignite. So first, the oxygen suppressant puts the fire out, and for the purpose of not having a possibility of reignition, water is spread in order to cool things down. That's a usual operation of that. And others, I just put that because it's a good idea to put that. Makes me look smart, right? There we go. Control elements of the fire alarm system. Well, there's a main fire alarm panel that's it's pretty much a given in all cases. You can control it through the laptop. You can program it through laptop. Internet protocol IP systems, so you can connect the laptop locally onto the system when you're on location. And sometimes if it's in another city and it's just a matter of diagnostic and programming involved, you could also access that through remotely, so remote access through the internet. Okay. Now, electrical code in effect, fire code in effect, licensing involved, right? So the installation and functionality of fire alarms goes in association with the electrical code in effect. That means that applies to the area you're in. Okay? And also there's a fire code that's it's basically like electrical code, but for the fire suppression systems. Right? And then licensing is involved when it comes to dealing with fire alarms. So, yeah, if anybody is interested in pursuing this type of avenue when it comes to doing whatever you're going to do in your life to make money, then talk to me. I will direct you to the specific persons here that could take up on your request. Right? All right, cabling that is involved with fire alarms. All right, fire alarm cable unshielded, fire alarm cable foil shielded, fire alarm cable armored unshielded, and fire alarm cable armored foil shielded, depending on, and that goes with the types of installations and the fire and electrical code that's involved in the area you're in. Sometimes you can just install regular fire alarm cable, and fire alarm cable, it's in the Ft6 configuration, and Ft6 is the jacketing. So you might want to pull out your electrical code book that you have, that you read to sleep. Wink, wink. Not really, but sometimes it's a long reading. So look at the differences between Ft4 and Ft6, as we are talking about Ft4 and Ft6. All right. And that has to do, the Ft4 and Ft6 standards have to do with the fire alarm or the fire conditions. Ft6 doesn't burn as quick as well, anything can burn if you get enough temperature, but Ft6 is more considered as fire retardant, okay, or fire resistant. So that means it's still going to burn, but much later than Ft4. So there are fire alarm cables. You can't just use any type of a cable to install fire alarm in fire alarm installation. You have to use a fire alarm. You have to use cabling that is designated for fire alarm. And as I said before, we could have fire alarm unshielded, shielded, right? The purpose of shielding that is mostly so you don't spread the noise, because there's not much noise that can be bothering the fire alarm installation because it's just an open or short circuit. But the fire alarm cables or fire alarm zones, they actually produce a bunch of noise, which can affect other devices. So sometimes in some sensitive areas, you might be required to install a shielded cables, shielded cables, so you don't spread the noise onto other devices. And in some cases, you might have to actually not just a fire alarm, but it has to be armored cable with aluminum kind of a casing there, and sometimes that can have that could be unshielded or it could be shielded, right? Security surveillance. How much time do we have? We have some time still. Okay, so we just finished up the fire alarm type of systems and security surveillance. So what is surveillance? Surveillance is basically security cameras, right? And here is an example of a control center for security surveillance. Security surveillance can be standing on its own and recording and nobody's watching it, and you're just going to go and review the sort of tapes or recording upon something happening. Okay, so one day you come to work and you see a bunch of garbage right in front of your door, and you're just going to see what happened. So you're going to go and review your security surveillance recording, right? Or in some highly sensitive cases, there could actually be a 24/7 human team that are watching a specific parking lot or watching specific locations. There will be higher security areas, right? You can buy services. Services can be purchased that companies that are offering watching your cameras, right? Well, everything is, of course, for a monthly fee, and those can be connected to your cell phones. You can review most of the security surveillance systems, the security cameras, are interfaceable with remote viewing access. So quite often, very rarely, you're going to see a system that you won't be able to use your cell phone to see your own cameras. Here's a example of a typical surveillance camera or security camera. What do we have here? Well, the older versions, and you still might bump into some old system where there is a coaxial cable connected to a camera, and that coaxial cable, which would be RG58 usually, and that would carry the video signal onto the main panel. And then there's going to be another cable, a pair, that would be supplying the power to that camera. So you would have two cables going there. And sometimes there's one cable that contains both. In one single jacketing, you will have a coaxial cable and a maybe 16 gauge one pair stranded conductors to supply the power. And in that case, it's called a Siamese cable, just like Siamese twins. Now these days, most of the cameras are IP cameras, pretty much all of them, right? Unless you get them through some online deals. That why is it that normally it costs $1,000 for a system and this one is like $300? That could be, the reason could be that the cameras are not IP cameras, right? But what are IP? Internet Protocol cameras that you use. What do you use? You use Ethernet. Everything goes Ethernet, right? You use Ethernet cable to connect, to make a connection between the main panel and the camera actually itself. What is this here? It's a power input. So you have an option quite often to power the camera from an outside power source, if you can find one close to the camera, or you can have another pair of cable going through that camera. So the Ethernet part would just supply the signal, and the cable would be supplying the power. What is becoming more and more popular and is becoming the usual standard of doing things. So even though you have that, you don't have to use it, because the camera also be powered by something that's called a PoE. PoE stands for Power over Ethernet, and we talked about that before, right? So that means that the Ethernet link is not only responsible for communicating the signal back and forth, but it's also providing a power on some of the pins, right? But now what happens is that the security panel, the main unit, would have Ethernet ports, and those Ethernet ports would have to be PoE enabled, right? Or able to provide PoE, or PoE made, PoE designed, PoE produced. It has to be present on that. The power has to be present. Some of the bigger systems, because if you make a box that is supposed to be able to provide the PoE on all the ports, then that adds to the more guts you have to put in there, right? And then the power has to be enough. The whole power, that is the PoE that is supposed to be distributed across all the ports, it has to have a certain amount of current delivery capability, right? So sometimes you're going to see one PoE, one section, like if it's a 16 cameras, you can see first 8 will have PoE and the second 8 would have no PoE capability. You have to read the specifications. When you purchase that, you have to make sure. And sometimes you're going to have to make sure that if you need to use more PoE ports, then you need to purchase another PoE injectors or PoE modules that are associated with the cameras, right? We'll go over that a little bit more as we go along here. We're almost done. Okay, so here is a typical residential type of or small business type of system here that involves the NVR. NVR stands for Network Video Recorder, or sometimes it's called DVR, which stands for Digital Video Recorder. NVR and DVR are exchangeable terms depending on who sells them, who makes them. Technically, NVR should be the one that can be connected to a network, but in reality, a lot of things that are DVR, which is just a digital video recorder, it also has networking capability. So NVR, DVR, in reality, they are exchangeable terms. If you really want to get technical, of course they are not. Right? So here would be the Ethernet ports, This one has 8. And here is a network port. Here is a VGA output for the monitor. And there's some other communication things. So over here, it could be something like security alarm zones. And those can be connected to motion sensors. And if there's a motion in the room, the system can be programmed so that the camera is being switched in onto the main view, or even the recording can be triggered, because sometimes the system is recording all the time, depending on how it's set up. Some of the systems record 24/7 all the time, whether there's a motion or not, or whether something happens or not. And some of the systems are just to save the hard drive space, because where does the information go? It goes onto a hard drive. So in order to save the space on the hard drive, the recording is triggered for a particular camera only when there's a motion present, right? So that could be solved by these motion sensors, or some of the systems, they sense movement onto the camera. If the picture doesn't change, the camera is at rest. If somebody walks in, of course the picture is going to change because somebody's walking in there, and that is going to trigger the recording on that. It says 48. How many up to how many volts? The PoE. PoE can be 48 volts usually, but there are other PoE systems that are 24 volts. Okay, usually that would be usually there's 48 volts, but just to make sure whatever system you got and whatever system you're purchasing, make sure that what is needed is actually the thing that you're buying. Right? Look at the specifications. Can run through Ethernet. Yes, it can. It does. Right? That's the idea of PoE. And usually the standard is 48 volts. All right. Now, when it comes to installing the surveillance systems, there could be one. Okay, so this here, you could have a small system capable of 8 cameras. Right? How can you connect the system? If it's an IP system or the IP cameras, it's NVR. You could connect those cameras directly onto this. Each camera goes to each port, and that's fine. But what you can do is you can have a switch programmed to receive the signal from the security cameras, in which case you don't have to use the individual ports here. The system can be plugged into a network, and the switch that has multiple ports can be also plugged into a network, and this circuitry inside can find the switch on the network and grab the signal from that switch and utilize it in its own circuitry. And that would be the idea of this. Let's say there is a building here, and there are a bunch of cameras. Maybe there are different buildings or different areas of the building. So in order to save wiring, like let's say this one has a bunch of cameras here. In the other far end of the building, there's a bunch of cameras. In the other far end of the building, there's a bunch of cameras. Or you can put remote switches there. It's just like a network switch. And to those switches, you can connect those cameras. So you will have maybe 3, 4, 9, 12 cameras, 24 cameras, and the cabling will be locally distributed into that switch. And over here, you would just have one, maybe fiber optic link or a couple of Ethernet cables. Instead of having all from here to each individual location, then you could solve it that way. Plus, you can only have 300 feet when it comes to Ethernet, so that sometimes the remote switches or remotely located switches are the only way to solve that if the distance is greater than 300 feet end to end. All right, so you can have a direct connection if it's a relatively small installation, or you could have kind of a partitioned system that And then of course the programming is involved. If every camera has an IP address and MAC address, and those have to be programmed into the switch, and they have to be sometimes into the switch, or sometimes the switch has to be recognizing them, and all those IP addresses and the MAC addresses are going to be programmed into the main NVR, and they're going to be all recognized. So sometimes you get direct connections, and sometimes you have the breakaway kind of a system. Right? That's as far as the topology. Okay. Security surveillance topology will be a star. So it's another way here. So here's the main network, NVR, network video recorder, and you would have all the cameras connected into a star. And this would be a tree type of a topology. Right? And this would be a star type of a topology. So there's the main NVR, and in star topology, the cameras connected directly. And over here you have main monitor, local monitor, or it could be also interface with the internet. So you could have remote access to all different paraphernalia to the system. And this is the last slide for today. We have gone 2 minutes over today. Security surveillance cameras. When it comes to using Ethernet cables, you need to have Cat5e minimum. It's not going to work on Cat5. And from the last or the second last presentation, you should be able to tell right now what the differences are between Cat5 and Cat5e. There's that table that I showed you. Right? So most of the time, now the standard of today is everything is connected through the Ethernet, and the security cameras are connected through the Ethernet as well. All right, so that's it for today, guys. As a reminder, for whoever joined or us right now at the last minute, please look at our YouTube list here. And on our YouTube list, there are those positions right here. You could probably notice that I divided our YouTube playlist. The top part is all the lectures that is being populated, and the bottom part, after the last lecture, is going to be a first lab. So, excuse me, there are these two last items here. That's the introduction to the optical fibers. This is your assignment. That's your homework, to watch these two videos during this week. One reason is that when I did those two, they came out really nice, and I'm not sure if I can repeat it in the same way. So I want you to watch that, and there could be other reasons that we might find out or not find out later why I'm doing this right now. Okay, I'm just covering all the bases. I want you to have as much information as possible that I can give you. Right? So okay, can run through it. Yeah, okay. I'm looking at the chat lines just to make sure that I didn't miss anybody's question. I love you, everybody, the same, and I don't want to miss anybody's question, and it looks like I didn't. Cool. All right, so that's the lesson for today, and I will see you when I see you next time. Thank you very much, guys.